Hi there, we will start a new paper, October, November 24, paper 23, which list contains only vector quantities. For acceleration here it is vector, distance scalar, speed scalar, electric field strength this is vector, momentum also vector, weight vector, energy scalar, mass scalar, temperature scalar, force vector, time scalar, velocity vector. So the answer here for vector only have B. The graph shows how the velocity of elevator varies with time. The elevator starts from the third floor of a tall building. Point B indicates the start of the elevator's journey. The elevator is in the third floor at point B. Then it moves a distance. This distance is the area under the graph. Then back. As the distance here equal to the as the area here equal to the area here, so it built back to its same place. So point Q also in the third floor, and of course point R in the third floor. For point S, the elevator moves with the velocity. We can find the distance traveled here and back again. We can find the distance traveled here. For A here the area here does not equal the area here, so we can't say that the elevator back to the third floor here in S be a long distance, so it's not the third floor. So the elevator will be in the third floor at point Q and point R only. An object of mass 1 kilogram is at rest on the Earth. An identical object is at rest on the planet with gravitational field strength of twice on the Earth, which law correctly compares the object on the planet to the object to the Earth. Its weight. The weight here between the gravitational field strength is twice. So the weight will double. The weight will double. Its acceleration when the same horizontal force resultant force is applied. When we have resultant force horizontal means like this. And if he talks about vertical force, so the force should be doubled. Okay, but he's talking about horizontal, doesn't affect by the weight or the gravitational field strength on the planet. So we take equal to the Earth. This is talking about horizontal, not vertical force. Question 4. An engineer researches the density of different liquids being used as coolants. We have a liquid and its density. Now, none of the liquids mix with water. Each liquid is poured in turn into a container of water. The density of water is 1000. Which liquid rises to the surface? So the density of water is 1000. So anything less than 1000 will rise to the surface. So we have X only. The diagram shows a car moving along a road. The force due to the engine is 1500 and the total drag force is 200 Newton. What is the motion of the car? If we check the two forces, 1500 here and 200 here, the resultant force is 1300 in this direction. So we'll have acceleration as we have force. So we have acceleration in the same direction. So the speed increases forward. pair of cutters is used to cut a rope. Uh, where should the rope be positioned and at which labeled points should the hands be positioned to produce the greatest cutting force? We need to put the rope at point we will have the maximum effect of the force. Of course, with less to the arm of force. So we'll put it at point Q. Here in the opposite, we put the handle away from the pivot at point S to have the maximum or the minimum force possible to cut the rope. An object has a mass of 20, its velocity from 6 to 10 meter square changes. Which impulse has act on the object? Impulse equals force times time, or impulse equal change in moment, which equals m delta v. M20 delta v change from 6 to 10. 10 minus 6 equals 80 Newton per second. So the answer is E. Number 8, useful energy is obtained from different energy resources. For example, of energy resources are listed: water waves, geothermal, wind, water behind a hydroelectric dam. How many of these energy resources depend on radiation from the sun? Water waves depends on the sun. Geothermal does not depend on the sun. It is the energy of the wind also depends on the sun. Water behind the hydroelectric dam also depends on the sun. So the answer is C. A box of mass 2 kg slides down on a slope. The gravitational field strength is 9.8. What is the decrease in the gravitational potential energy stored as the box moves from P to Q? Change in gravitational potential energy equals mg delta h. M, the mass of the box, is 2 kilograms times the gravitational field strength 9.8 times change in height. We talk about the vertical height here only 5. Vertical height only. So we talk about 5. So the answer is 98 joule. Diagram shows a part of a long jumper. Point R where she lands on is on the same horizontal level as point P. From where she takes off, the long jumper experiences air resistance as she runs and jumps. Which graph shows how stored kinetic energy and the stored gravitational potential energy on the long jump vary with time between points P and R? For the dotted lines, kinetic energy. For the gravitational potential energy, this is the solid line. He said here, the long jumper experiences air resistance. So it means that kinetic energy changes to potential energy and air resistance and work done against air resistance. So the kinetic energy gained here from P to Q is transferred into potential energy and work done against air resistance. So in these graphs, the kinetic energy, as you see in dotted line, it changes from maximum to minimum, then maximum, as in graph B and in graph D, but does not reach 0 in graph B and D. What difference between B and D? In graph A and A, the kinetic energy reaches 0, which is not correct, but in graph B and C does not reach 0, which means there should be some energy to overcome the work against air resistance. And as you see here, the minimum point, which is here, and the minimum point, which here, kinetic energy should be more than here. They are equal, but here they are not equal. So, as we said in the first place, not the kinetic energy is not equal the gravitational potential energy because there's work against air resistance. So choose graph B. It's not equal.